All right, are there any questions on the homework assignment, page 3 and 4? Any questions on pages 3 and 4 of the homework assignment? Did you have your take-home test? I don't know if I gave you one or not. And then page 3 and 4 of your homework. Yeah.
So what is it on number 13?
13, come early. I will give it right back to you. So page number 13. All right, number 13. Okay. All right, so if you go to work this out, first thing I would do is take care of these like terms right here first. Don't go moving anything yet, just make sure. And then you also have these like terms over here. So I'm going to combine those. So on the left side, you get 2x. On the right side, you're going to get negative x, and then you get plus 12. So this yields this, and this yields that. Does that make sense? From there, so that wasn't moving anything one side or the other on that. So now I can do my dotted line. I can add x to both sides. X is the same thing as 1x. So those cancel, so that's 3x is equal to 12. And then divide each side by 3, x is equal to 4. Okay? Does that seem okay? Perfect. Make sure you print your name real clear on this. And you'll return that today. Did you have a take test? Okay, so that comes up today, so you can have to. And then do you have a take home test? I can't remember what I did. Okay. Other questions from the homework? Anything else you came across that might be? Yeah. 21? How about it? I'll do it right back. Number 21, we have 3y minus 2 equals 2y plus 8y minus 4y. Okay? All right, I do have like terms on the same side, so I'm going to take care of those first. Is that okay so far? And then I can do my each side. So let's see, I will maybe add 2y to both sides. So that's 5y minus 2 equals 8. Add 2. So that's going to give me 5y is equal to 10. Divide each side by 5. So y is equal to 2. Yeah. 19. 19. 12 minus 3x equals x minus 4 plus 4x. That one? Cool. All right. Again, I still have some like terms over here. These are like terms, so I'm going to combine those first. So 12 minus 3x is equal to 5x minus 4. Let's see. I can then do my dotted line. And I'm going to go add 3x, add 3x. Those cancel, so I get 12 is equal to 8x minus 4. Add 4 to both sides. So I get 16 over here equals 8x. Divide each side by 8. So I find that x is equal to 2. Did that one?
Anthony something. Is there Anthony?
Nope, we answered. So this is what we do if you're absent. I go put it over here in the circular file. Unless we have recycling, we don't have recycling, okay? So it should be there tomorrow. If it's not, then we know it's at the landfill, so. Any other questions from the homework? Go once. Twice. So, all right. Pass those, make sure your name is printed so I can read it, please. And pass it on forward. Please. Good to go. Thank you. Thank you. Thank you. Appreciate it. And appreciate it. Well, what's my hiccups? Any more homework? Questions? Okay. So, this is going to be notes for today, so I'll be handing these out. So I was talking with my parents over the weekend, and they're up in the state of Washington for the summer. They go there for the past 8 years, and they enjoy it, which is cool. And I will tell you, you know, as a teenager, don't you think sometimes your parents say silly things where you're just like, say what? Because I don't know, me as a dad, do that to my daughters, and they're like, whatever, Dad. But it continues. So even at age 46, and my parents are in their 70s, they still say funny things. Have a nice trip. See you next fall. So my dad says to me, are you going to be able to see the eclipse on Monday? I said, yeah, we're going to see 93% coverage. Oh, is it? Oh, it's 96? Okay. Close. So,
Internet says it's 93. Internet's always late, so.
that's okay. Well, it's in the 90s. So, which means, so if it's 93 and 96, let's cut the difference and call it 94 and a half. Sound good? Or even 95. That means that the moon will be in front of the sun like a real good solid A. Agree? So my dad says, well, why isn't it going to be full coverage down there?
Oh boy.
So I said, well, the path of the sun and the moon at that point don't allow it this far south to be 100% coverage. So my mom says, yeah, Atlanta, Georgia is the only place that'll have the eclipse. I said, no, there's a path of the eclipse that goes across the entire continental United States. How do you know? It's been on every news station, newspaper, and internet site for the past 3 weeks. Oh, we only get the local news here. So I said, where are you guys located? So I live up where they're located. They're going to have 98% coverage where they're at. I said, you guys have almost a total solar eclipse. Are you sure? And I'm thinking, I'm never going to get this part of my life back in this conversation. This is my own parents. Boy, I love them to death, but... And then take it this way however you want. So, my father feels that email is awesome, which is great. But email's been around for a long time. Okay? My dad thinks email is so awesome that anything that is sent to him, he needs to forward on to everybody because everybody must see it. Now, I have even sent my dad an email saying, hey, this is the itinerary for, when we'll be down in Arizona. And then I'll go check my email again, and I'll see that my email that I sent to him was forwarded not only back to me, but to everybody in my dad's address book. So, Dad, why are you emailing everybody my itinerary of when I'll be in Arizona? Oh, I didn't realize that. But you didn't respond to my email saying, yes, I'll be there. Great, can't wait to see you. Anything. No, he forwards everything. So this is a man that spends way too much time on the internet, wastes way too much people's time on the internet, forwarding everything that comes to him, because that must be vitally important. But they are the same people that, how did I know that there was a path across the United States?
Oh, I get it.
So the amount of time you spend on the computer, I mean, honestly, you go to like MSN.com or you go to Yahoo.com or any site. No, the computer's still on.
Maybe check your paper now.
Well, Reggie. Hey, means I'm gonna have to teach the old school way. All right. Don't worry, I know how to do that too. So, regardless, I just thought, how funny is it that they don't realize that information? I don't know. Love my parents, but boy, oh boy. I sometimes wonder how half of my DNA came from mom and half of my DNA came from dad when they aren't able to figure out the obvious. All right, I'm going to teach here today, okay? Huh, can't believe that projector went. That's too bad. So, let's see. Get this squared up on there. And it'll pick it up. All right, solving linear equations, multi-step equations. So many steps, right? So we've been working with multi-step, where sometimes we have like terms that we have to combine that are on the same side of the equal sign. Sometimes we have to move things back and forth across the equal sign. And then it goes with that. So our warm-up looks like this. So we have 4x plus 5 is equal to 2x minus 11. Question number 1, I just want to walk through it. And I know sometimes it might be a little slow walking through, but in order to get everybody on the same page as everybody, do I have like terms on the same side of the equal sign on this?
No.
I have 4x plus 5. Are those like terms? No. Is 2x minus 11 like terms?
No.
No. Okay? So from there, I'm like, I don't have like terms. So here's my dotted line. I know it's not quite as fancy as the other one. So I have to start picking. Maybe I'll subtract 2x from each side. And those cancel. So I get 2x plus 5 is equal to negative 11. Makes sense, right? We're trying to isolate the variable. From there, I could probably subtract 5 from each side. So I get 2x equals negative 16. Divide each side by 2. So I get x is equal to negative 8. Seem all right? Next example, I have y equals 2y plus 1. Do I have like terms on either side there? Not at this point. So I'll draw my dotted line in. So what should I do with this one? So yeah, subtract the 2, or in this case 2y, but you're absolutely right. So subtract that, those cancel. That leaves me negative y is equal to 1. Technically, we multiply both sides by negative 1 to wind up with an answer of y equals negative 1. Seem good? Next, we have 3x minus 2x equals 6 plus 4x. Do we have like terms on this one, on the same side?
Yes.
I do. I have 3x and minus 2x. They are like terms. So let's combine those together. We're not moving them across. We're just combining like terms. So that's going to give me x is equal to 6 plus 4x. From there, we have our dotted line. What should I do? Subtract 4x. So you bring the variable over. I like it. Subtract 4x from each side. Again, we're trying to isolate. Those cancel out. So x minus 4x, 1 minus 4 is negative 3. equals 6. Divide each side by a negative 3. So we find that x equals negative 2. Am I going too fast? All right. So that's a warm-up. We've been doing that, we're doing that, and doing that. Okay? So as we go a little bit further on this, that next slide has a bunch of boxes, which the first one says distribute. Next one says multiply by the least common. And I don't know what the rest of the boxes are, so I'm actually going to turn the page. I'm sure there's something really cool I should have filled in there, and it will probably help you with the meaning of life, but I can't do that. Okay, so the one thing you have to remember is if you have the parentheses. So if you had this, or if you had this, square brackets, they're grouping symbols. Make sure that you understand to distribute everything here to here and to here. That would give you A times B plus A times C. Is AB and AC, are they like terms? No. The B and the C aren't the same, so they're not like terms. So if you have parentheses or square brackets, make sure you distribute over the parentheses. So we have example number 1. I believe this is the problem. Is that a k plus 8? Okay. So from there, I'm going to distribute what over the parentheses? Yeah, the 3. I saw a lot of hands. I'm just choosing people. So I get 3 times k, which is 3k. Stays positive. 3 times 8 is 24. And it's going to be equal to 21. Is that all right so far? I'm going to make my dotted line. The dotted line represents a equal sign. So next step might be to subtract 24 from both sides because it's a positive 24. So I get 3k on this side. Those cancel each other out. 21 minus 24. Negative. What? Negative 3, right? Oh. If it was 21 minus 4, you're absolutely right. It would have been 17. Sorry about that. It would happen. Okay, so cancel. That's k equals negative 1. X would be, if you ever interchange, if we have a singleton letter and you want to change them to X's, that's totally fine. It's a conversation that actually came up yesterday in my house. Why do us math teachers start changing the letters? Hey, I don't have a good reason. I don't know. Just to allow you to represent that it's not always X, maybe? Perhaps. All right, so this next problem, I have negative 2 out front, and then I have x minus 3 is equal to 12. What do you feel you should distribute over the parentheses? Yeah.
The negative 2 over the...
Yes, good. The negative 2, that negative's got to come around. So whatever the sign preceding this number is, that has to distribute to both. So I have negative 2 times x is negative 2x. Negative 2 times negative 3. A negative times a negative is a positive. Get that? Agreed? Does everyone feel comfortable how the signs worked? Dotted. All right, so it looks like I can subtract 6 and subtract 6. So I get negative 2x equals 6. Divide each side by negative 2, divided by negative 2. And I heard it, x equals negative 3. Absolutely. Can you all see that okay? Sorry, it's not electronic. It's so old school. Yeah?
So if you're distributing a negative 2 times 3, wouldn't that be negative 2x minus negative 6?
Well, because I have a negative here, so I'm going to show you I think I can answer that question doing one thing. This right here is the same exact thing as doing that. Okay, plus a negative, reduction of signs is subtraction. And that's why it would changes the sign. Is that okay how I said that? So if you had, anytime you have a subtraction, like if you had minus 5, That's the same thing as saying plus a negative 5. Adding the opposite, because subtraction is just adding opposite values. Everyone done writing for a sec? Let me get this next example up. Okay, put your pencil down for a moment. I want you to all watch this. Huge error that takes place in math is the order of operations does not take place. What should I distribute over the parentheses, do you think, up there? Yeah.
-2.
Yes. So I'm not adding those together or subtracting them. That -2 has to come here and to here. So notice this 6 comes straight down. Then you get minus 6x plus 10. Same reason. Negative times negative is positive equals 40. Now you can go ahead and pick your pencils and pens that back up. But I want to pause there while you're writing. Think about that. What did I do? I did not combine 6 and -2 together. I distributed what was prior to the parentheses first. And that first 6 comes along for the ride. We good so far? I do have like terms. These are like terms here and here. So I have -6x plus 16 equals 40. Okay? And then subtract, do my dotted line, subtract 16. What does that come out to? I got -6x, cancel, equals 32? 42? What? 24? 16? What? How much is it?
24.
24, yeah, good. 24, divide each side by -6. So lo and behold, you come up with an answer of x equal to -4 because you had 24 divided by -6. Good?
Yep.
So far? Happy? This next slide, I apologize. We're going to use the F word. Fractions. Okay? We're using the F word. Fractions. It's here. All right. Now, what's neat about doing this, this is a great skill that I almost wish they would teach you in elementary school and you would be able to avoid all fractions at all costs in elementary school. Because I know, like, you all, like me, you were probably set with adding, subtracting, multiplication was fine. Then you got the whole division thing, and then we decided, oh, you didn't really like division. Here, I'm going to trick you. And now I'm going to give you a fraction. And guess what a fraction really is? It's a division problem. So why don't you like fractions? You didn't like division. So, look at this skill. Watch this skill. This is cool. I think it's cool. I have 1/3 x plus 1/2 is x is equal to 10/3. Now, you all might think, oh, let's get a common denominator. Yes? And this is where you start getting that weird twingy feeling in the back of your stomach, your adrenal glands sitting on top, your kidneys are firing because you're like frightened because there's a fraction up there. You're like, I don't do so well with fractions. Neither do I. So let's go through it. I'm going to show you a skill of how to clear your fractions. And I think you're going to totally like this skill. Okay? Some of you might have heard it before, if not. So first thing I need to do is I'm going to take a look at my denominators. I have a 3, a 2, and a 3. So what's the smallest number that both 3 and 2 go into evenly? 6. Everyone feel comfortable with that?
Yeah.
Okay? So what I'm going to do is 6 is our magic number. So I'm going to multiply this by 6/1. I'm going to multiply this by 6/1. and I'm going to multiply this by 6 over 1. Now, if you multiply fractions, what was the rule that elementary school teachers always wanted you to do before you multiply? Starts with an R, ends with a D. Reduce. Reduced. Okay? Watch this. Ready? Eyes up here. 3 goes into 6 twice. Agree? 2 goes into 6 3 times. Agree?
Yeah.
3 goes into 6 twice. Agree? So what's on the bottom right here?
1 and 1.
So 1 times 1 is?
1.
I don't even need a fraction anymore. 2 times 1 is 2x. Plus, what do we have on bottom here? 1 and a 1, so I don't even need the fraction. 3 times 1 is 3. And then, what is this one? 2 times 10 is? What's now missing from this problem? No. What's missing? What don't I have anymore? Fractions. They're gone. Oh, this is easy. 2x and 3x. I add those together because they're like terms, so I get 5x. That's equal to 20. We're done. Look at that. Dotted line. Divide by 5. Divide by 5. X equals 4. Yeah.
How'd you get the 6?
So I looked at the denominators, and I had a 3, a 2, and a 3. So I had to think, what was the smallest number that both 3 and 2 went into? And 6 would be that smallest number. So I chose to multiply everything by 6 over 1, and then just reduce the fraction. That's it. Fraction's gone. So that life skill that you thought you needed to know, and they probably tried to cram in the last 6 weeks of 3rd grade, you don't have to worry about the fractions. I just showed you a skill to make sure that you never have to deal with a fraction on a problem again. That's pretty cool. Nice. Can I move to the next one? Can I erase?
Yeah.
All right, so looking at this next problem that's up there, we have, let's see, we have a over 15 plus, that's plus, right? 4 over 15 is equal to 9 over 15. Okay, we at least have common denominators, yes? But I don't want it. So what I'm going to do is I'm going to multiply all 3 of my fractions by 15 over 1. That goes into there. I'm just left with a. Plus, this goes in there. That leaves me 4. This goes into there. That leaves me 9. Subtract 4. A equals 5. Done. No fractions. Starting to feel a little better about yourselves? Adrenal glands have settled back down. You know what the adrenal gland does? That's your fight or flight mechanism. Either you're going to, man, we got to throw down, or I'm running like crazy to get out of this thing. Yeah?
It's just say a plus 4 equals 9, just subtract 9 from 4, and you got the answer without having.
In this case, because it's all the same denominator, I bet you that would work over and over. I like that. Good job. All right, this one I have 2 over 3 plus y equals 3 over 4. Okay, so 2 of the 3 terms have a fraction. Yeah. Yeah, so what's the smallest number that both 3 and 4 go into? 12. Good. So I'm going to multiply this by 12 over 1. I'm going to multiply this by 12 over 1. Is 12 over the 1 the same thing as 12? Yeah. And multiply this by 12 over 1. So 3 goes into 12 4 times. So what do I have right here? 8 plus, this one didn't have anything to cancel, so I just get 12y. 4 goes into that 3 times. What do I have over here? 9. Subtract 8. Subtract 8. Those cancel. 12y is equal to 1. Divide by 12. Divide by 12. Y equals 1/12. Okay, so you get a fraction for an answer. But you know, you didn't have to work with fractions. Sweet. Love this stuff. Okay. Somebody have... I'm going to do this because I'm going to run out of time. Does somebody have their book? You open your book real quick. I just want to see what page it's on. All right. Yeah. So I want you to get a good try of page 7 and 8. And the reason I'm saying a good try is I wasn't able to get through all of the notes because we have the short period. So if I say try, you think I'm going to be able to put a top, middle, or bottom mark on homework tomorrow?
No.
I bet you're going to come to a couple problems you're like, ooh, ooh. So try as much as you can. And why don't we just go through it entirely tomorrow? Any questions you might have had on the homework? Sound like a deal? Pages 7 and 8, yes. Sound good? So again, it's just a try. Don't get much further than 15 minutes outside of class working on that assignment. Give me 15 honest minutes, and that'll be a good try.
Pretty good.